An object that has spent millions, perhaps even billions, of years drifting through the emptiness between stars has finally entered our cosmic neighborhood. After an unimaginably long journey across interstellar space, this mysterious traveler has become one of the most fascinating targets ever observed by the James Webb Space Telescope. For the first time, scientists are getting an incredibly detailed look at an object that did not originate in our solar system, offering a rare opportunity to study material formed around another distant star. Known as 3I Atlas, this remarkable visitor is only the third confirmed interstellar object ever discovered. Earlier visitors, including Oumuamua and Comet 2I, Borisov, sparked worldwide curiosity, but they were either detected too late or observed with limited technology. This time is different. Thanks to the unmatched sensitivity of the James Webb Space Telescope, astronomers can examine the object's composition, structure, and activity in extraordinary detail. Rather than appearing as a simple point of light, 3I Atlas is surrounded by a faint cloud of gas and dust. As sunlight gently warms its frozen surface, tiny amounts of ice begin turning directly into gas, creating a delicate glowing envelope known as a coma. This subtle activity transforms the object from a silent rock into a living record of processes that have remained unchanged since it left its home star system. Using its advanced infrared instruments, Webb can detect details completely invisible to ordinary telescopes. Infrared light allows astronomers to look beneath the surface dust and identify the chemical fingerprints of the materials that make up this ancient traveler. Every spectrum collected by the telescope tells a story about where the object formed and the environment it experienced long before our solar system even encountered it. Early observations indicate that 3I Atlas contains frozen water ice, carbon-rich compounds, silicate minerals, and a variety of complex organic molecules. These materials are considered fundamental ingredients in the formation of planets and may also play an important role in the chemical processes that eventually lead to life. Finding these substances inside an object from another stellar system suggests that the basic building blocks of planets may be surprisingly common throughout the Milky Way. That possibility has excited astronomers around the world. If distant planetary systems produce similar materials, then many stars across our galaxy could be surrounded by worlds that formed under conditions not entirely different from our own. Every interstellar visitor becomes a messenger carrying valuable information from places humanity may never directly reach. When researchers processed Webb's first observations, they immediately realized they were looking at matter that had never belonged to our solar system. For countless ages, 3I Atlas wandered through the vast darkness separating one star from another before gravity guided it through our cosmic neighborhood. It represents one of the few opportunities humanity has ever had to directly study material born around a completely different sun. Even more surprising, Webb detected ongoing activity surrounding the object. Instead of remaining completely frozen and inactive after its immense journey, sunlight has triggered the release of trapped gases beneath its surface. Thin jets of vapor slowly escape into space, carrying tiny dust particles that form the faint glowing cloud surrounding the nucleus. This behavior closely resembles that of comets within our own solar system, suggesting that 3I Atlas is still evolving despite spending unimaginable lengths of time drifting through interstellar space. The object was first discovered by the Atlas Sky Survey, a network of telescopes designed to search for potentially hazardous asteroids approaching Earth. At first glance, it appeared to be another ordinary moving object. But careful calculations quickly revealed something extraordinary. Its path through space followed a strongly hyperbolic trajectory, proving it was not orbiting the Sun. Instead, it had arrived from the vast regions between the stars. Ground-based observatories around the world immediately began tracking its motion, but only the James Webb Space Telescope possessed the infrared sensitivity needed to uncover its hidden chemistry. Operating far above Earth's atmosphere, Webb captured light that never reaches ground-based telescopes, allowing scientists to investigate the object's composition with unprecedented precision. One of the most fascinating discoveries is that the chemical signatures hint the object may have formed around a star quite different from our own, possibly a cooler red dwarf. If true, this means researchers are examining material created in an entirely different stellar environment. Instead of simply studying another comet, they are analyzing a small piece of another planetary system that somehow survived an incredible journey across the galaxy before briefly visiting ours.